Exercises from page 119 from our textbook. We completed the exercise number 2, but I still have it on the screen because I'm just recycling the same program. So you can see that we had an exercise before where if the hours were greater than 40, we were going to change the value of pay rate by multiplying by 1.5. So you still have that exercise on the screen if you'd like to pause and see the code. So the new exercise 3.3 is a program that deals with commission rates. It's very common for people that work on commission to have different percentages of their sales on commission depending on a different target value. So for this exercise, the target value is 10,000, and if the sales is greater than 10,000, I made a typo there. If it is equal or more than 10,000, then the commission rate was going to be 0.2. So we take a look at the data type of the different values, and we have sales that the value that we're going to compare to is 10,000, so that's a whole number, so it's going to be an integer data type. And then the commission that is 0.2, so that's going to be a double. So I edit the previous code accordingly, where the declarations I use the same data type. We had an integer and a double in the previous exercise, so I just need to change the name of the variables and the values. Since sales, the target value is 10,000, I'm going to assign the value. Actually, I started at 0 because we initialize all the variables so the program will work. And the commission is also initialized to 0.0. So I'm going to change the condition to compare to 10,000. So we're going to say if sales is greater than or equal to 10,000, then the commission needs to change to 0.2. So there you go. If sales is greater than or equal to 10,000, then commission needs to receive the value 2.0. So I purposely initialize both values to 0, and I do the first run with that value in sales. So what's going to happen is that when I run this program the first time with sales equal to 0, then the condition is going to be false. So the condition is going to be false. So the value of commission is going to stay at 0.0. Normally, when we're having programs that have if statements, we need to make sure that we run the program several times. So see, the value of the commission has not changed because we started the sales to 0. So 0 is not greater than or equal to 10,000. So now I'm editing it so the value of sales starts at 10,000. So they're going to be equal. So when I run this program, and remember, every time you change a value, you need to build it. Then when you run it, now the value of the commission rate has changed to 0.2. So what happened was that the condition was true, then the if statement is executed. And remember the syntax of the if statement is if, condition, no semicolon. In the next line, we indent and it's an executable statement, so I write it the same as before. So now we have a value that is greater than 10,000, the condition is true, and the value changes for commission to 0.2. So that was exercise 3.3. Now we move on to 3.4, and I'm going to edit the program from before. And this is an exercise that works with a Boolean variable. So this is something that is new to us. So Boolean is a variable data type that can only take two values, true or false. So then when we set up a condition with a Boolean variable, we do not need to say if the name of the Boolean variable is equal to true, because the condition can be true or false and the Boolean can be true or false. So then we can sort of write it the way we speak. If Boolean variable name, blah, 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 do something. So we have a Boolean whose name is Max, and I'm initializing it to false, and then I'm going to run it with the opposite value, true. So normally we initialize variables to a value that is like the starting point, right? So we initialize sales to 0, fees to 0. If we were dealing with a grade, we may initialize a grade to a -1. So if the program is not working correctly, you will see that the value has not been set to a new value. Okay, so back to this exercise. Boolean max equals false. So I initialize max to false. That way I know that I'm not going to go through the if statement. And the int fees equals 0. So if max, so see, if max, I don't need to say equals to true. So if max, then fees equals 50. And then the output statement. So I don't need to say if max equals true. We mean if max. So editing the output statement for cosmetic reasons. And now I'm going to build the program and run it. So you see that there's no syntax error. And now when I run it, I get that fees. I had a typo in my output statement, so it kind of looks like a funny smiley. So I go there and I fix the output statement. So fees equals 0 is what I should have seen. So now I run it again, and you're going to see that it works correctly. So this program ran, but the if statement did not execute because max is false. I changed the value of max to true. I build it and I run it, and now it's going to show me that the fees changed to 50. So if you recall, when we have a true-false variable, we call that a flag. That is in our lecture video and in the textbook. So this is taking a little bit of time, but I wanted to make the information explicit when I set up this exercise. And that way people get used to comments and so forth. So now I'm going to build it, and because the condition is checking if max is true, and I have initialized max to true, now the value of the fees has in effect changed. Yeah, so it changed. And now we're going to move on to the last exercise from the textbook, 3.5, which is what is special about the last exercise is that the if statement needs to execute multiple lines of code if the condition is true. So please don't forget, if you have an if statement that needs to run multiple lines of code when the condition is true, then we need to put curly braces to make that block a unit. If we forget to put the brackets for multiple lines of code, the outcome is that the program is going to run. You do not have a syntax error if you forget the brackets, as long as you don't have an else. So if in these exercises that we have if statements without else's, if we forget to put the curly braces, the outcome is that only one line of code is inside the if, and the other lines will execute regardless of condition. So we have to be very careful, because if we just have if statements without else's, the program will run anyways, and it is a logical error that you will have to debug it yourself. So we need to make sure that we put the curly braces when there's more than one line. So we have 3 integer variables, x, y, and z, and we're going to assign a different value to y and z using x in the condition. So the exercise reads, write an if statement that assigns 20 to the variable y, so that's one of the variables that we modify, and assigns 40 to the variable z if the variable x is greater than 100. So in the if condition, we're going to change that to z. So since we're checking for x greater than 100, I set up x to 101, so the condition will be true, and all the lines of code that are inside the curly braces will execute. So now I'm going to change that older code to the assignment statements that assign a 20 to the variable y and assigns a 40 to the variable z. So y equals 20, yeah, per the exercise description, and now we need to assign 40 to z, so z equals 40, semicolon, and then the output statement. In the output, it would be a good idea to list all the variables, not just the ones that we modify, but because we're running the program with different variables with different values for the variable that is in the condition, it would be a good idea to echo the value of the variable that we use in the condition. So I believe I ran it with just the 2 variables once, and then I show the change to include the variable that is in the condition. So it shows you that it went inside the if statement because it modified both values, the y and the z, because I have set up the initial value of x to 101. And again, this could be a randomly generated number, it could be a number typed in by the user. So to make sure that we know what we're dealing with, it would be a good idea to display also the value of x. So I think this is when I edit this and I include the x in the output statement. Yeah. And I'm using escape sequences because the information that I need to display is pretty short and to the point, but there are multiple values. So for that reason, I'm using the escape sequence that sends the cursor to the next line to make it aesthetically appealing in the output and short in the terms of how many lines of code I typed out. So I'll build it and then run it, and there you have it. When x is 1, then y and z did not change the value. So remember, every time you run the program, the variables are initialized, right? So every time I run it, the value of y and z are set to 0 again. We don't keep the values 20 and 40 from before. So now when it's 101, the values are 20 and 40. And that's it.